Hi, me again. I want to show you just how to balance redox equations in 6 easy steps. And also to show you, I'm using Google Meet here and Microsoft Whiteboard. So these are some of the tools that I work with when I'm tutoring or doing classes or trying to demonstrate what's going on. So it's stuff that I can share with you quite easily. So I'll have this problem here. And on the left, I have the flow diagram, which has the 6 easy steps. So in the first instance, step 1, work out the oxidation numbers in the equation. So I'm going to look at bromine in this one. And just to note that with the oxygen and the hydrogen, you see that these are present as compounds, and oxygen and hydrogen have fixed oxidation states when they're in a compound. So for oxygen, which means that in these equations it's bromine and nitrogen that change in oxidation number. So if we look at this bromate here, we see that the 3 oxygens, that would give us a total oxidation number of 3 times -2, which would -6. This whole ion has a charge of -1, which means that 5 of those 6 negative charges are being cancelled out by the bromine, and therefore the oxidation number of bromine here is +5. Let's make that size appropriate. Now, if we do a similar thing with the nitrogen, we see that these 4 hydrogens here, they have an oxidation number of +1 each, so that's +4, which basically means the nitrogens, because this whole thing is neutral, those nitrogens must come to -4 in order to balance out that +4 from the hydrogen, and there's 2 of those, which basically means that each one of those is going to have a -2. So that 2 times -2 is going to give us -4, which would give that overall molecule the total of the oxidation number 0. So if we look at bromide straight on the other side, this is a relatively easy one because it's just a straightforward ion. The oxidation number is the same as the charge on the ion. So here it's -1. And in the nitrogen, again, less difficult than before. This is nitrogen being an element, so the oxidation numbers is 0. So step 1, we work out the oxidation numbers of the elements that we're interested in an equation. The next one is to identify changes in oxidation state for oxidation and reduction. So if we have a look here, with bromine, we can see that the oxidation state is going from +5 to -1. So we see that the oxidation state here is decreasing. And what that tells us is that that is a reduction. So a decrease in oxidation state tells us that what we have is reduction. And the opposite of that, an increase in oxidation state, is what's happening here with the nitrogen. When we see it's going from -2 and it's going up to 0, then this is the oxidation state with the oxidation reaction, where the oxidation state is increasing. So that's step 2, is simply to identify what's been reduced, what's been oxidized. Step 3 is to balance the changes in oxidation number. So this is where we're going to get numerical. And I'm going to put in a ruler here. I find this sort of very helpful to actually use a number line. You might prefer to do your number line horizontally. I prefer to do them vertically here. So just get rid of my ruler now so I can put these in. So the highest oxidation state is +5 and the lowest oxidation state is -2. So I want to put those all in. +5, 4, 3, 2, 1, 0, minus 1, minus 2. So I'm going to write those in there. And then have a look at what is going on. So in our reduction, to make my pen a bit smaller, in our reduction, we are going from +5 to -1. So here we see the oxidation state is going from +5 to -1. And that represents a change of 1, 2, 3, 4, 5, 6. So that represents a reduction in oxidation state of -6. Now, if we look at the oxidations, now we look at nitrogen. And we see that the nitrogen oxidation state is going from -2 to 0. So that is going up 1, 2, plus 2. So I've got a thick pen at the minute. Let's have a less thick pen. But we also notice that here there are 2 nitrogens here and 2 nitrogens here. So that's happening twice. So we put that in brackets. Now, the next thing, once we have identified these, we need to balance them. So the minus and the plus need to be equivalent. So we can see that we would need to do this +2. We would need to do that 3 times in order to balance that -6. Okay, but there is a problem with that because you have an even number here. In order to get those nitrogens balanced, effectively doing that oxidation change 3 times, you're going to have to multiply this by 1.5. So in order to avoid using the halves, we just double everything up. So we double that up as well. So this should give us -12, and I'd already counted the 2 in here, which is why I multiplied it by 3. So 2 times 2 is 4 times 3 again gives us 12. So this is the 2 from the equation. So what we have here is we can start to balance our equation by taking 2 of those and 3 of these. This would give us, if we were doing this twice, 2 of those, and we would need to have 3 of these. So what this effectively is saying, for every 2 of the reduction that we do, so for every 2 of these, we need to do 3 of these doubles, or 6 of these, of 6 nitrogens effectively in total. So our next step, because we're not quite finished yet, balance the other elements. So if we look at the hydrogen and the nitrogen, so here we can see that at the moment we have 2 hydrogens and 1 oxygen, but that's not what we've got on the other side. If we do 3 times 4 here, we have 12 hydrogens. We do 2 times 3 here, we have 6 oxygens. So if we take 6 moles of water, you see that 6 times 2 now gives us 12 hydrogens, and 6 times 1 oxygen gives us 6 oxygens. This step here is not relevant particularly in this equation because we're not using acid or alkali conditions. And the last thing to do, just as a check, is to check that you balance the charges or the charges are the same on the left hand side and the right hand side. And what I mean by that, if you take the bromate 5 ion, you have 2 of those, so the total charge on the left hand side is 2 times minus 1 is minus 2. So this is the left hand side. So they're not always neutral because we're using half equations. And if you look on the right hand side, you see that the water's neutral, the nitrogen's neutral, and we have the bromide, and we have 2 of those. So 2 times that 1 minus is also given as a 2 minus. So we're writing a charge on the ion. So we mean 2 minus rather than. So what we see is we have the same charge on the left hand side and the right hand side. So now our equation is balanced. Our redox equation is balanced, and it's not necessarily as straightforward as just doing a straightforward balance this equation, because if you do that, if you tackle this as we normally would balance an equation, this is not what you would get. Okay, I hope that makes sense, and I shall talk to you soon.